Hi everyone. So we'll wait for 5 more minutes for others to join, and then we will start the session.
Good evening, sir.
Good evening. Okay. So before starting, can anyone please confirm whether uh, week 9 practice assignment was discussed in previous sessions or not?
Yes, sir. It is discussed.
Okay. So today we are going to discuss the topics that are there in week 10, and then finally we will solve some practice assignment questions. Okay. Let me Pull up the whiteboard. I hope my screen is visible.
Yes, sir.
Okay, so first of all, the first concept is like you might have seen that for trains and stations, we used to show the details using some graphs, right? Suppose we have a train T1 and there is another train T2, another train T3. Okay, and let's go first by station, and then we can go train by train. Let me clear this up. Okay, so suppose we have a station S1, S2 is there then, and then we have S3. Okay, so we connect S1 and S2 when there is a train from, suppose from S2 to S1, we have a train. So this edge is basically representing that we have a train between S1 and S2. And the source is this, the source is S2 station and the destination is S1 station. Similarly, we can have some trains which is again going from S2 to S3 and then from S3 to S1. Okay, so these kind of things we can represent using that. Now, when you process these graphs using some scripts or programs, you can't directly pass these graphs as it is to a program, right? So for that, we have two kind of representations. One is adjacency list. Okay, one is adjacency list, and the second one is adjacency matrix. Okay. So in week 10, we have discussed about this, and I think in the previous weeks, you might have seen this. If not, I'll show what is that as well. So basically, adjacency list will represent something like this. Suppose we have S2, okay, and we will show the mapping from like suppose we start at S2, which stations can we reach? So from S2 we can reach S1 and S3, right? Similarly for S1, if we are at S1, we can't reach anywhere. What about S3? If we are at S3, we can reach
S2.
S1.
only S1,
S1.
right? So this is adjacency list representation. Okay. So we will have the mapping between stations. Now, when we have to process a graph like this, suppose we have a question where we have to check from, suppose we have the source station and we have this destination. Okay. And we have to check in how many ways can we reach S2, S1. Okay. From S2, how many ways can we reach S1? So from this graph, you can clearly see that there are two ways, right? Either we can directly go from S2 to S1, or we can use the intermediate station S3 and then reach S1. So there are two ways. But during programming, you are able to see through the graph, but when your program runs, it won't be able to see this particular graph. Okay, so in that case, we can provide the program this representation. Okay, or there is one more representation which I'll show now. So we'll create a matrix. So the matrix will have these things as rows and columns. Okay, and we will have one when suppose we have to check whether S1, from S1 we can reach S2 or not. Okay. So in this matrix, if it is reachable, we will have 1, otherwise we will have 0. So for all the diagonal elements, we will have 1, right? Because they are the same station, so they will have this kind of representation. Let's see, from S2 we can reach
But it
S1 or
will
not.
be zero
Yeah,
Which one?
the
all the
same
diagonal elements.
row and same column.
Uh, are we using 0 in these, in the lectures?
Yes, sir.
Yes, sir.
Okay, that is fine. Let's use 0 then. Okay. Now from S2, can we reach S1? Yes, right? That is
Yes,
an edge. So we will use 1 over here. From S1, can we reach S2?
No,
no,
We can't. So this will be again 0. From S3, from S1, can we reach S3? No.
no.
From S2, can we reach S3? Yes, right? Now from S3, can we reach S1? Yes, this is 0. Correct?
Yes, sir.
So in your program, either you can use this representation or you can use this representation. Okay. Now, if you see this particular representation, we have this path as well. So from S2, we can use this path, right, to reach S1. Suppose this edge was not there. Okay. So in that case, from S2 to S1, this will be 0, right? Now, suppose
yes,
if
sir.
we have to check whether from S2 to S1, can we reach or not? Okay. So if we have to check this from this matrix, you will say no, that is not possible, right? Because we have 0 over here. But if we use one intermediate station and check, then we should be able to reach S1. Correct? So this matrix is basically representing direct connections. Okay. All the stations which are all the stations which are directly connected. Okay.
Yes, sir.
Then we have concept of one hop connections. Okay, where we will have an intermediate station, and from that station we should be able to reach the destination. So let me clear some of the things first. Okay, so for that, how can you check? So let's see. From again, we are writing the rows and the columns. These are again zeros. Now we can see that from S3 we can reach S1, right? And again we can see that from S2 we can reach S3, right? So from
Yes.
S2 we are able to reach S3, and from S3 we are able to reach S1. So there is a possibility. So for that particular station, okay, we can write 1, because there is an intermediate station which we can use to reach the destination, right? Again, for let's first complete this row, then we'll move forward. So from S1 we can see that we can't reach anywhere, so there is no intermediate station at all. From S2 we can reach S3. So S3 is possible, and then S1 is also possible. If we use single hop, we can reach S1 as well. Okay. What about S3? From S3, we can reach S1.
Yes, sir.
And what about S2?
No.
We can't, right? So this matrix is basically representing your one hop connection, one hop distance connections. Okay. So
But how
similarly,
we
we
can
have,
know difference between these two matrices?
they are different. No, this element. See,
But how we can know which matrix is which?
okay. So like if a matrix is given directly, you can't directly tell whether it's a one hop matrix, two hop matrix, or direct connections. Okay. So in the question or in the statement, it will be provided that this is a two hop matrix, one hop. So those details will be already provided in the questions. Okay. Now, along with this, the question will have that detail. Now, suppose we in the question it is asked that from S2 or from a station, which other stations can we visit? Okay, in zero hop maybe that is direct connection, then one hop, and maybe till four hop. Okay, if that is given, then you have to check all the matrices, or you can just directly create this one. Okay, but for that you have to check the previous matrices. So once you do that, you will reach this matrix, and from this matrix you can directly say that these cells have one, so this and this are connected. Okay, is it clear?
Yes, sir.
Okay, so now this representation is basically showing you whether there is a connection or not. Okay. Now, sometimes, like in the previous example itself, we had S2, then we had, I think, S3 was there, then S was there. This was connected like this was connected like this was connected like this. Okay. Now, suppose from S2 to S1, there is just one train, and that train is maybe taking, um, it is basically traveling maybe 40 kilometers. Okay. And this distance is maybe 15 kilometers, and this one is the 10 kilometers. Okay. Now you can see that from S2, there is two possibility to reach S1. Okay. Now while traveling, you want to travel basically the smallest distance. Okay. There are two paths, but you want to take the smallest path. So from the previous matrix where we had just one for connections and zero for no connections, so you can't directly interpret this, right? You can see that
Yes.
S1 is connected, but you can't interpret that this particular path is the smaller one, but compared to this one, right? So that comparison you can't do. So for that, can you do something? Any idea?
In place of 1 and 2, we will be keeping the distance.
Yeah,
So with 1 and 0.
correct. So we'll have the same thing. We'll have the row's name, the columns name as the stations. Now we will keep the distance itself. Okay. So from S1 to S1, it is 0, S2 to S2 is 0, S3 to S3 is 0. Now from S2 to S1, we are talking about direct connection right now. So it is 40, as you can see. What about S1 to S2, it is 0. This one is also 0. S2 to S3 is 15. And S3 to S1
10.
is 10, right? Now from this
Sir,
matrix, yeah,
so one question that if it was not a direct connected train, so in that case, the matrix will not contain the distance.
correct.
So in that case, how to represent the matrix?
Again, we will do the same thing. Like previously, we created one matrix which was direct connections, right? So this
Yeah.
is representing the same thing, direct connection. Now, after this, we can have single hop, double hop connections, and from that we can interpret. Okay. So
Okay, okay.
if we create the single hop matrix,
So the
so
matrix will be different, right?
yeah, it will be different.
Okay.
So this will be 0, this will be 0. S2 to S1. Previously we had 40, right? Now there is one more path, which is this one, right? So
Yes.
we can
25.
Yes.
just take minimum of 40 and 25. So it will return what? 25, correct?
Okay.
Now S2 to S3 will remain the same. S3 to S1 will remain the same. And okay, so now we can see that there is a smaller path, and that path is taking just 25 kilometers. Okay,
Mm. So one more example, can you give?
same thing. Distance
So
one,
that
In,
means
no,
we
or
will
no,
always
in
be
two or
calculating
three
the
hops.
smallest distance.
2 or 3 hops.
2 or 3. Could you repeat that? What did you say?
I am telling that with 2 or 3 hops.
Okay, 2 or 3 hops. Okay, we will have to go to a larger graph.
So
Yeah,
that means we always calculate the shortest distance in between.
that depends on the problem, right? In some problem, it might ask the shortest distance. In some problem, it might want to have
It
direct
means according
connection.
to the question.
Yeah, in some question, like it doesn't make sense, but the question might ask you to give the longest distance. Okay, so that depends on the question itself. I hope that is clear. Okay, so let's move to a larger graph. So I'll show you 2 hops because going to 3 hops and 4 hops will be basically the same thing, but it will take a lot of time. So let's see 2 hops only.
So the question may also ask for time, means
Yeah,
the shortest time needed.
so in that case, what you will do instead of representing this on the axis, you will have an hour, something like that. Okay.
Okay, okay, okay.
So let's see. S1 we have, S2 we have, S3 we have, and then we have S4 maybe. Okay, let's try this example. Okay, so this is a graph basically. Let's try to see what we are getting. Okay, from S1 to S2, we have 5 kilometers. From S1 to S3, don't have direct connection. 0. S1 to S4 is 18. S2 to S1 is no connection. S2 to S3 is no 10. S3 has zeros only. What about S4? S4 has just this one. Okay, is it clear?
Yes, sir.
Yes, sir.
Now let's move to one hop. S1, we have S2, we have S3, we have S4, and S S2, 3. Okay, so from S1 to S2, we already had this path, and from the graph, you can see from S1 we can reach S2 in just one way. So I'll just write 5 for this one. What about S1 to S3? Is it possible in one hop? It is right. From S1 you
Yes,
can
sir.
go to S4, and from S4 you can go to S3. So that is 20. For S4, you have to see the minimum because the direct connection is 18 and the indirect with one hop is 15 only. Okay. So what you will do is you will use 15 over here. Okay. From S2 to S1 we can't reach. From S2 to S3 we can reach in 12. S2 to S4 will remain 10. What about S3? S3 doesn't have any connections at all. What about S4? S4 has
Three
just
will be two.
S3. Okay, so this is your one hop connections. This is
Okay.
for the minimum distance. Okay,
Okay.
Sir, we can go one more way from S1 to S3, like
S1 to S.
S1 to S2 and S2 to S4, and after that S4 to S3.
We were talking about single hop, right? So there will be just one intermediate station, and then we will reach. In
Okay,
two
sir.
hops, we can have that path, right? S1 is there, S2 is there, S3 is there, S4 is there. Oh, 0, 0, 0. So from S1 to S2, can just write 5 because there was just single connection, single way. Now S2 to, sorry, S1 to
So
S3,
it would be zero, right?
which one?
S1 to S2 because you are calculating for two half.
So this problem is saying the problem statement here is basically whether you can reach from some source, okay, to some distance in 0, 1, or 2 hop or not. Okay, so this is first thing,
Okay.
and then you have to find the minimum. Okay,
Okay.
got it?
Yeah.
So that's why we always consider the direct connection in hop also.
Direct connection in hop. What do you mean by that? Could you elaborate?
In first half and second half, he is telling.
Yes. Yes, sir. Directly means there is a S1 to S2, there is just direct connection, and we are creating one hops. That's what I'm asking.
Yeah, yeah. So we are considering all these three. Okay.
Okay, sir.
So that is why suppose if we have from some source to some destination direct connection and there is no other connection, we will use that direct connection. Okay. For this problem statement. Okay.
Okay, sir.
Yeah. Now from S1 to S3, we previously had S1 to S320 and now we will see whether there is a two hop
17.
connection or not. There is, and the distance is 17. So we will use that. And then S1 to S4 is what? 15? There is no other connection. Yeah. There is no other way. So for that 15. S2 to S1 will be this. This will be this. And this will be this. Okay. S3 doesn't have anything. So zeros. S4 had just one. So yeah, this is it. Any doubt in this?
No, sir.
Okay. So that's pretty much it for week 10 theories. Now,
Sir, one question.
yeah,
So for one hop only, we have to check that whether the station from the destination station to the arrival station is reached by one hop or not. If it is more than one hop, then we will not consider the right for one
correct,
hop,
correct.
and for two hop we can consider it.
But again, that depends on the problem statement. Okay, so in some cases, if you are checking for exactly, okay, exactly two hop.
Yeah. So I have to take two hop in that case.
So what I discussed is this, right? Whether you can
Yeah.
reach from some source station to some destination station in these allowed hops or not. Okay. So in
Yeah.
that case, you will take both. Okay. Got it? So if
Okay. Okay.
you are considering two hops and there is a destination which can be reached from source in single hop, as per this, you will take it. Okay. But if you are talking about exactly two hops, okay, so there is some
Yes.
source station and there is some destination station. You are saying that whether we can reach the destination in exactly two hops or not. Will you
In that
consider it
case, so we have to take the two hops only.
only two hops? Is it clear?
Okay. Yeah.
So
Yeah.
then in that case, we will not take the direct edges.
For two hops, you can't. You won't
Oh,
take.
okay, sir.
Okay. So that's pretty much it for the theories. Then we have pseudocodes and other things. So those things you can check. And if you have any doubts, you can ask. Now we will proceed to some practice assignment questions.
Sir,
Yeah.
what is meant by degree?
Okay. Degree. I can. Okay. Give me 1 minute. Yeah. So degree is basically in terms of a node. Okay. So suppose you have a node and as you can like in the previous graphs we had some arrows, right? And some arrows were going from a node towards some other node and some node was coming some nodes were coming, right? So let's say we have a node, and maybe that is S1, and we have another node S2. Okay. So first of all, are three things. So first is degree. Okay. So in degree, you will check all the arrows. Okay. All the edges. So incoming and outgoing, all. Okay. So for S1, we have three, right? Three arrows are there. Two are incoming and one is outgoing. So the degree of node S1 is 3. Okay. What about S2?
One.
For S2, it is 1. Okay. So this is degree. Now in degree, we have in degree, okay, and out degree. As the name suggests, in degree is basically incoming edges and out degree is outgoing. Okay. So for S1, we have number of incoming edges is 2. So in degree is 2 and out degree is 1. Is it clear? For S2, the in degree is 1.
Out degree is 0.
Yeah, in degree is 1. Out is, sorry, 0. Is it clear?
Yes, sir.
Yes.
Now let me pull up the practice assignments and then we can discuss.
Sir, the first pseudocode of week 10, I am unable to understand.
First pseudocode.
Means
Okay.
on lecture 3, I think the first one.
Lecture 3. Let me pull that up.
Sir, I'm not able to see the screen actually.
I am not sharing right now. I'm putting up the question. After that, I'll show.
Okay, sir.
I hope you are able to see my screen now.
Yes.
You said lecture 3, right? This is week 9.
Week 9, this is.
Yeah, yeah. This one, right?
Yes, sir.
Okay. What are you understanding here? What's your doubt?
The doubt is in the what Madhavan said told. I am not able to understand in the first 3 or 4 lines. Means the station is a dictionary of what, and for each T in keys of trains, what does it mean that each T means the trains, each trains,
Yeah.
and what does station indicate? Means what does the dictionary indicate?
You can see this. So stations is over here. It is empty. Okay. And then we are adding these things. Okay. So trains is basically trains is what? Trains is list of trains, right?
Yeah, yeah.
Okay, it is saying keys. It is a dictionary. 1 second. First compile the list of stations. Start and end. So trains is a dictionary. Okay. Now in train we had suppose we have a train T1. This is the index we were using, train number basically. Okay.
Okay.
Now for this train we had some start and end, right? So the start was what? The source station,
But yes,
right? And
yes.
we had some destination. It could be some intermediate station as well. So this is the format for trains, and we will have multiple trains. Okay. Now from this format, in a stations, we are picking what? Trains of. We are picking trains of T and then a start. Okay.
So in this part, I cannot understand. What does it mean?
What is this?
Okay, okay, okay. This is a dictionary. Okay, got it. Yeah,
Yeah.
so we
And
have to take the start and map it to true.
yeah. So here, as you can see, we have a start and end. So this one is also not list. This is again a dictionary. We will have two keys: start, which will represent your source station as one, and end is
Yeah.
your destination. Okay.
So, sir, what does here you have written the train is a dictionary, but here written in the pseudocode, original pseudocode, it is written the station as a dictionary.
Both are dictionaries. Both are dictionaries. So here, from this line, you can interpret that trains is a dictionary, right? Because we are using keys of train,
Yes,
and keys is all only available
a
for,
dictionary.
right? So the format for train is something like this. Okay.
Okay.
So do you want me to explain the whole thing, or will you see it and then interpret?
I can do it, but if you tell a brief about this, means wrap up.
So
Should
we
be
created a matrix, direct route matrix, right? Direct connections. Study is basically trying to do the same thing. Okay.
yeah.
Now we are creating a stations dictionary, and it will have basically the list of source station and the destinations, which can be reached in a single hop. Sorry, in which can be reached directly without any hops. Okay, zero hops. So basically, sir is trying to create that. Once that is done, so this is basically adjacency list that I showed you, right?
Okay. Yeah.
So it's similar to that. After that, we are creating a matrix. So for that, we are initializing the matrix. Then we have this variable, two variables we have initialized, and we are creating the index. Okay. So for
Yeah.
each stations, we are creating index. So in the matrix, I was using this kind of representation as you could remember. Okay. So we had some rows and columns, right? So instead of using these names directly, we have to create indices because matrix are what? Matrices are list of list, correct?
Yes.
So in programming language or in Python or in CT as well, for list we use this kind of notation or indexes, right? So that's why that is mapping, creating a map between the stations and some numbers, which will basically be treated as the indices for those stations. And finally, we are over here, we are populating the matrix. Got it?
Yeah.
Yeah.
Thank you, sir.
Yeah. Now let's move to the practice assignments. We'll quickly discuss the questions and Yeah. Consider the following condensed version of trains dataset. There are n stations, with the stations being indexed from this to this. There are m rows in the table. Each row contains information about a train that connects to stations without any stops in between. For example, the row tells us the train T departs from station I and arrives at station J after covering a distance of this kilometer without stopping at any intermediate station. In other words, the rth row in the table corresponds to two consecutive rows in the card for the train's data set. Is it clear what this table is representing? Is it clear?
No, actually.
Okay. So in train data set, if you remember, we had some stations, right? S1 and S2. Then we had some days, maybe one only. Then we had some time was also there, and distance was also there, right? So suppose the train is started over here, then for S1 it covered 400 kilometers, and for S2 it covered 700 maybe. Okay. So these kind of details were there in the train cards. Now, one particular row in this table is representing this data. So we have train ID. Okay. So we had IDs for all the trains. So that is there. Then we have departure and arrival. Okay. So as you can see over here. Okay. So departure and arrival are basically the stations. So this is basically representing S1. This is maybe S2. Okay. From our example. Now we have D. Now D is what? D
Yeah,
is
what
the
the train?
distance. Okay. How much distance the train covered while covering this particular thing from going from S1 to S2 or I to GA? How much distance does the train cover? Like for this particular example, it covered how many? How much distance? 300 kilometers, right?
Okay.
So that is what the table is representing. Now can move to the pseudocode. The scenario is modeled as a graph. So we have a graph given, and that graph is being represented by matrix A. Each node in the graph corresponds to a station, assume that the value of n is already given. So you consider the following pseudocode. Okay, so we have a pseudocode given over here. First, let's try to decode what it is trying to capture or create. So we have an empty dictionary over here. Now we picked one row, and that row is basically one train going from station I to station J. Okay. Now we populated x dot sequence number. What is x dot sequence number?
Train number.
Yes, it is train number. So I'll just write T. Now we are sorry, that is not train number. Train number
It's actually
is
a
over.
sequence number.
That is sorry, sequence
It's
number.
actually a
This one.
sequence number.
Yeah, it is this one. The index. So S is their essence, some sequence number, let's say SEQ only. Then we have another dictionary, and we have train as the key. Okay, and train is basically some T. Then we have departure. So DP departure. What is departure?
Starting
What is
station.
this? Yeah, source station or a starting station. Okay. So I'll write as for this one.
Sir,
What? Yeah.
sir, I think departure will be a separate dictionary like train dictionary. Means inside the sequence number.
Yeah, it is inside. This one is a comma. This particular one is a comma. This is a comma. Okay. It's not closing the dictionary. Okay.
Okay.
Now arrival is basically the destination. Then we have some distance. Now over here we are closing this one, and we will have some more sequence, and then finally we close. Yes. Is it clear?
Yes.
Is the format for S clear?
Yes, sir.
Okay. So if that is clear, now we'll move to A. So first of all, from here we can see that A is a matrix of size n cross n. So n is basically the number of rows. Okay, number of rows in the table. Now over here we are iterating over A. Okay, so A is basically this, and we are iterating over the rows and columns of A. So it will give us a cell. So suppose we have n as 3. Okay, suppose we have this as 3 only. Now this is our matrix, and each element we are initializing as empty dictionary. Okay,
Yes, sir.
so is this part clear? I hope this is clear. Now what about this one? Now for this one, we are iterating over the keys of S. So what was the key of S? Key of S was sequence number,
Sequence number.
correct? So X is some sequence number. X is representing some sequence number. And from that, we are getting R, C, T, and D. Okay. So some sequence number was there. Let me again write the format of S. So we had this. Then inside this, we had train. Then we had departure, arrival, and then distance. Okay, so these 4 keys were there. Now in R we are storing departure. Okay, in C we are storing
Right.
arrival. Then we have train and we have distance. Now can you tell me how this will change this particular dictionary, the internal dictionary?
Will it be nested dictionary?
What do you mean by nested dictionary? Dictionary inside
Means
dictionary?
yeah, I'm not sure about it. Just guessing.
Okay, let's try to decode this.
So I think A will be a
What
dictionary.
is A of RC? First of all, let's see what is A of RC. We have this. what you will get from this?
Each element in the matrix.
Yeah, so it is basically targeting one cell. Okay. And in that cell, we currently have empty dictionary, right? Now we are adding T in it. Okay. So in the dictionary, the internal dictionary, we are adding T. What is T?
Train.
It is a train. Okay. So can I write something like this as the key? Now we have distance. So we are mapping this to distance. Now for this single element, can we have multiple of these trains? What do you think?
Can you
Sir,
repeat it?
but
So this we got, right? Now for this particular cell, we have an empty dictionary, and after doing this particular thing, we got a train inside that, okay, which I represented using T1, right? So is it possible to have some T2 as well with some distance D2 in this particular cell itself? Can we have it?
Yes, we can. Why? Because it's inside the for each group, right?
That's true. Okay. So we can have multiple things, multiple trains between a source station and a distance station. Is it clear?
yes, sir.
For this particular thing, the correct answer was that depends on the data set. Okay. If we have multiple trains between a source station and a destination, then we will have multiple of these things inside a single dictionary. Otherwise, we will have just single train and single distance. Okay. So is the mapping clear? What is there in your matrix? So each element in matrix A is the mapping between a train and its distance. Now source is what? Source is your row is your source, okay, and destination is your column. So from if we talk about this particular element, so your source is what is the ID for this row? This is 1, right? And this one is 0. Okay. So from one station 1 to station 0, we have some train, let's say T1, and it is taking maybe 50 kilometers. It is covering 50 kilometers. So that kind of data is stored in A. Is it clear?
Yes, sir.
Okay. If anyone has any doubt related to this, you can ask now because we will now proceed to the questions. So this particular matrix, A matrix, will be used there.
Sir, why can it have two trains in the
Again, as I mentioned, that depends on the data set. If the data set has multiple trains between two stations, then we will have multiple elements in a single cell. Otherwise, we will have just one. In real life, like if you travel from maybe Chennai to Bangalore, there can be multiple trains, right?
yes, that's the case.
That's the case. So that depends on the data set. If the data set has that kind of data, then it will have multiple elements. Otherwise, it will have only one train. And for some cells, it might not have any trains at all because some source station and some destination station can't be connected as well, right? There is a possibility that there is no train between those stations.
Yeah, okay.
Okay.
Yes.
I hope the format for A is clear. Now let's move to the questions. So if ij is pair of stations, which of the following statements about the dictionary ij are true? This is an MSQ. So is the first option correct? Option A, is it correct? Each key corresponds to a train that goes from station I to J without stopping at any intermediate station. Is this
Yes, sir.
correct?
Yes, sir.
Okay, so option A is correct. What about option B?
Yes.
No, sir.
Option B is not correct because
Yeah.
in the setup itself, it was mentioned that you see this line without stopping at any
Yes, sir.
intermediate station. So it is just representing the direct connections. So option B is
Sir, if
incorrect.
it is not told in the question, let's say, then as it is a MSQ, then can it be correct? No.
Yeah, it can be. If it is not mentioned in this question stem, then you will pick this. Otherwise, you will skip. Okay.
Oh,
What about C? Option C. The value corresponding to T of the dictionary is the distance between the station I and J on T's route.
Yes, sir, correct.
Okay, this is also correct. What about option D?
it can be.
How? So option D is not correct because we are talking about just a single train. So there is no concept of minimum maximum there, right? It's just distance, correct?
Yes, sir.
Yes, sir.
Over here it is saying minimum, so there is no concept of minimum in direct connections. So and if we are just talking about a single train and direct connections, there is no concept of minimum distance. So that is incorrect. So option A and C are correct. Otherwise, all the options are incorrect. Okay.
Yes, sir.
Let's see question number 2. What does the value length of keys of A, I, J represent? So what is it?
Option B, sir.
Option B. It is the number of trains that go from station I to J without stopping at any intermediate station. Okay. So option B is the correct one, and all the other options are incorrect. Now this question is not related to the previous matrix. So let's see what is happening over here. IJ min is a procedure that accepts a pair of stations IJ and the matrix A as input. It returns, I think it is using the same matrix. Okay. So since nothing is mentioned about A, so we will just use the same matrix. It returns a train which goes from I to J by covering the least distance. Okay. Without stopping at any intermediate station. If there is no train connecting these two stations, the procedure returns -1. The pseudocode may have mistakes. Identify all of them. Okay. Is the problem statement clear?
Yes, sir.
Okay. So if that is clear, then tell me which lines do you think are incorrect? I'll show the options as well so that you can check. Line number 3, is it correct or incorrect? Does it have any error?
It's incorrect.
So this line doesn't have any error, right? Incorrect as in, does it have any error or not?
Sir, in question, what we have to return?
Yeah. So basically, we are given the A matrix that we created in the previous questions. Now we have a procedure given over here, I j min. It is taking three things: the A matrix, some station I, and some station j. Okay, and the procedure is supposed to return the train which goes from I to J by covering the least distance without stopping at any intermediate station. Okay, so basically, as per this question, so in each cell you have some trains. Okay, now this procedure will basically check all this and return the train which is going from some source station I to J by covering least distance. For this particular example, the procedure should return T2 because T2 is taking D2 distance and that is less than D1. Okay, I hope that is clear. Now, based on that, line number 3, is it correct or incorrect?
I think it has no error in line 3.
There is no error. Okay. There is one more line that I would like to highlight. It's this one. If there is no train connecting these two stations, the procedure returns -1. Okay.
Is incorrect, sir.
This is incorrect. Why? Because over here we are returning false. But
False.
as per
Okay.
the problem statement, we should return -1. Okay.
Yes, sir. Yes, sir. Sorry.
Yeah. What about line 5? Line 5, is it correct or incorrect?
It's
Correct.
correct.
It is correct. Okay. And why do you think it is the correct one? Any supporting statement for this? Why is it correct?
Sir, I think it's checking the trains between station I and J. First keys AIJ.
So basically, we have a dictionary, right? This dictionary you have to keep in mind. Okay. So whatever operations are happening, most of them are happening on this dictionary itself. Let's try to first decode this and then let's move to the options. Okay. So in line number 5, we are taking first keys of A of I of J. So that is this string. Is it correct or incorrect?
But why we have to take the first one?
That's a choice this procedure is making. I'm not saying you have to take the first one. Let's try to go through the full thing, the full procedure, and then we can decide. Is this clear that line 5 is basically assigning train is equal to T1 as per this data?
Yes.
Okay. What about min? What is min? Again, as per this data only.
Minimum distance.
What is the value? Min is not saying minimum distance, it's just taking this A of I of K of A.
That means it will be a D1.
It's given. Okay. Now we are iterating over the rows. What were the rows of this? Tell me what is the data type for this one first. What's the
It's a
data type for
matrix.
this? This full thing. It's matrix.
Yes, it's a matrix. And we can also say it's a nested dictionary.
We can't have two data types for a single variable, right? So A is a matrix. A is a matrix. Okay. What about A of ij?
A of
A is
IJ written station names.
A of ij returns station names. Isn't A of ij this mapping, this particular dictionary?
Yeah, but it accepts pairs of stations, right?
Pairs of state.
In the starting itself, it says IJ equals to pairs of stations.
Yes.
Yeah, that is true. That is true. But I'm talking about the data type of one. Data type or value, you can say. Now,
It is also a dictionary, which is on the right side, right?
yeah, it's a dictionary, this dictionary. Okay. Now, in this dictionary, as you mentioned, IJ, for this particular thing, we don't have the concept of IJ. Okay. Because IJ was what? Pair of dictionary. Now, in matrix, we have the concept of IJ because the rows and columns will be some station, but inside that we don't have the concept of a station. Okay. Once you are inside the cell, you just know this data. Is it true? Are we on the same page? Or do you want me to play it a bit more? Okay, so A is this particular matrix. Okay, when we say A of some I, it will give us a list with some elements. Okay, and that list will be basically this row, right? Now, when we do A of I j, so that means from this list we are picking the jth element. So suppose we have some jth element over here. Now we are picking this element. Okay, so that is there. Now this element is what? This element is one cell, correct? Now this particular whole thing is one cell of it. Now see that in the previous question, I had showed you each element of a cell, right? Each element in the cell A. So it was something like this only. Is it true? Am I audible?
Yes, sir.
Okay, so is it true that each cell is something like this?
Yes, sir.
Now, if that is true, can we say that this particular thing that I just circled is of this format only?
Yes, sir.
Are we on the same page, all of you? Are you able to understand this?
Yes.
Okay. So, if that is the case, then tell me whether line number 7 is correct or incorrect. What do you think?
Line number 7 seems correct. Line number 8 doesn't.
Line number 7 seems correct. Why? Why do you think it is the correct line?
Because we are calling rows out of that matrix.
Not matrix. This is a dictionary. We are calling rows on this dictionary.
Mm,
That means it's wrong.
then it should be keys, I guess. No?
Yeah, we don't have the concept of rows in dictionary.
Yeah.
Okay, so line number 7 is incorrect. Now, what about line number 8?
Sir?
Yeah.
Instead of K, it should have train.
Instead of K, it should
Because previously in line number 6, we have marked the specification. Train.
that is some
But we
like
used in line number 7K, right?
K is basically we are iterating over all the train, and for that iteration we are using K, right?
Mm-hmm.
Line number 8 seems correct to me. Think about it. You are just picking the distance for each of these trains. Okay. So you are iterating over this particular dictionary, and for each train, in each iteration, you are picking this
So again in
distance.
line 11 we are equalizing this to train equals to K.
What is the problem statement? So it is saying you have to find the train which is going from I to J by covering the least distance. For least, what do you need to do?
Minimum
You need to
distance.
minimize right? And when you minimize, since you have to return the train name itself or train ID itself, you have to reassign it, right? If this particular thing is correct, you have to reassign, right? You will update two things, the minimum distance and train ID.
Sir, one more thing. What did we figure out about the line 3?
Line 3 is incorrect.
Incorrect, right?
Yeah, this is, it should return -1, but it is returning false, right? So it is
Okay.
incorrect. So I'm clearing the whole thing now. And line number 3 is incorrect, as we figured out. Line number 5, we haven't figured out yet. Line number 6, we haven't figured out yet. Line number 7, we said that is incorrect. What about line number 8? Are we on the same page?
Yes,
Yes,
it's
sir.
correct.
It is correct. Okay. What about line number 9?
It is also correct.
Yep, correct.
We are checking the current distances less than the current
Minimum.
Minimum.
global minimum or minimum that we have stored as a variable or not. If that is the case, we are updating the minimum value and the train value. Correct, right?
Yes.
Now we are returning train. So do you think line number 5 and 6 are incorrect or correct? So to find a minimum, uh, we need two things, right? So we need to initialize something, right? So we might have solved many minimization and maximization problems. So to minimize something, you need to store some value or initialize minimum to some large value, right? Now, in this case, what we are saying is we picked a train, the first train itself, and we saw that it has some distance, maybe d1. Okay. Now we are saying that this particular distance, we are saying that we are assuming that this is the minimum distance in the beginning without iterations. And for this minimum distance, we have a train which is represented over here itself. We have a train, suppose T1, so that we have also stored. Now we have started the iteration. Okay, we are checking each train and distance pair, and if we found that for some distance this is true, then we will update both the values. And if we don't found, if we don't find that thing, then we will return just this train. Right? Someone's mic is on. Can you please turn it off?
Manu.
So your wallpaper is nice actually.
So sorry.
Yeah. Is it clear?
Yes, sir.
Okay, so line number 5 and 6 are correct. They don't have any mistake in them. And we found that line number 3 was incorrect and line number 7 was incorrect. Other than that, we don't have any incorrect lines. So let's see the options. So A is the correct option and line number 7. B is the correct option. Otherwise, all the options are incorrect. Okay. I hope this is clear.
Yes, sir.
Move to the next question now. let ij be a pair of stations which of the following statements are true after executing the pseudocode given below. So we have ij here. We are using the same matrix A. So if length of keys of A of I is not equal to 0, then I to J is true. If this is this, then A to I is true. I both K false, and then we are saying if both are true, then it's true. Okay. What about these options? Is this pseudocode understandable? Are you guys able to understand this, or do you want me to explain? Any doubt in the pseudocode? What is happening?
Sir, what is I both? I didn't understand. Correct.
What is I to J first?
From I
What
to
is
J.
this? What is this variable trying to represent? When we have I to J true, what does that mean?
It is not equal to 0 when
What is not equal to 0? This one? This thing? Now, what does that mean? So we have some A, right? We have the matrix of the U. It has some elements, and the elements were something like this, right?
yes,
Now we are doing this. So keys of A of ij not equal to 0. Okay, and we are
yes,
picking the length. So what is A of ij? A of ij is this particular dictionary, right? There is some
yes,
mistake in the question. There is a mistake in the question. It should be something like length, then keys, then A of I and J, and then we have to close this length. Okay, so length will be closed before the comparison, the zero comparison. Okay, it's not closed right now, so that is incorrect. Okay,
yes, sir.
now for
Got it,
this,
sir.
there is some incorrection over here. So basically, what it is trying to see is like keys of A of ij will basically give us what? All the trains, right?
It's just syntax error, right, sir?
Yeah. So it will basically give us, for this particular example, it will give us T1 and T2 as a list. And in that list, we are doing the length operation. So it will, for this particular example, it will give 2. And now we are comparing 2 with 0. Okay. So if it is not equal to 0, that means we are saying that there is a train, at
True, it
least
is
one
true.
train from I to J. Okay. Is it clear?
Yes, sir.
So I to J is basically saying there is a train from I to J. Similarly, J to I is also saying the same thing. There is a train from J to I. What about this one?
When both condition true, then it is true.
Yeah, that means there is a train from I to J and from J to I. Okay.
Yes, sir. Got it.
Now, what about the options? Option A, is it correct or incorrect?
No, false. It's not
False.
correct.
Okay. What about this is all of it?
B option is correct.
Option
Option B is correct. Option A is incorrect. Yeah.
Option C
What
is
about
also
option C?
option C is also correct, I think.
If both I is true, then this and this are also true.
I think that it is
Yeah.
also.
Which thing you didn't get?
Yeah, sir. What about that C?
Option C is basically saying we have two trains. Okay, we are able to go from I to J and from J to I. That means there is some train from I to J and J to I, right? Got it?
Yeah.
Yep.
What about option D?
Can't see it, sir. It's too.
Option D
It's,
you can't see?
no, it's under the screen. Screen share. Can you show all the options right away? So it would be much easier to say which is correct and which is not.
Yeah. I think they are visible now.
Yeah. Till G is visible. G is under the
Yeah,
Zoom interface.
That the D also.
I think you have
Sir, option D is right, na?
Yeah, option D is right.
Option D is correct.
How can you say option D is correct?
It's false. Either will be false, right? Or both will be false. If F is,
If you are saying there is no path, like this is not true, that means either this is not true or this is not true,
sir,
right?
it's an AND condition.
Yes, sir.
Either both of them false will also return false.
But
Yeah,
it is the reverse of that option C. Only true and
it is reverse of option C, but you're not covering all the possibilities, right? It could be this, or this.
Sir, we are considering cases over here. All the cases are written in the options. We just need to select positive cases.
Yeah.
So yes, in that case, it will be correct. It's one of the cases.
Sir, like when I to J is wrong and J to I is also false, then I both J will be false.
in that all thrice
For
there. If
for
someone
this particular option, it is saying that we know that both I, J is not true. Okay, that is false. So does that mean that this is true? We are saying this, but we don't know, right? It could be something like this. There is no path at all. Okay. It could be something like this, that there is a path from I to J, but J to I is not true. Or it could be this one. Also.
so basically what change in that option D so it will become true.
It won't become true, right?
Okay.
It has this given, and from this you have to interpret. So in the interpretation, you should say all these three conditions, right? Either there is a path from I to J, okay, and J to I is missing. So that is first condition. Or there is a path from J to I, but IJ is missing. So that is second condition. And third condition is there is no path at all.
Okay.
Okay. So that's
Yeah.
why this is incorrect. What about option E?
That is also false because
Then
That is also
sir,
false because it is
we would say we
covering.
don't know.
Yeah, it is just covering one of these cases. So it is saying that this is there, but it is not talking about this condition and this condition, right? So it's also incorrect. What about option F? Same thing. It's saying
thing.
about I to J, but not about.
it is similar to option E.
Yeah. What about G? Is
Again,
it covering all the cases or not?
it will be the same situation, right?
Yeah, it will be or
Yes.
option, and in that option D there is an end. So I think it is maybe correct option Z.
Yeah,
Option G is correct.
option D
Okay.
is correct.
Yeah.
Any doubt in this one?
No.
So we have three correct options: B, C, and G. Okay, let's see. Okay, so these are the correct options. Let's move to the next question. SumProc is a procedure that accepts three parameters: train, station, and the matrix A that was computed in the previous question, which are the following statements about its return value or true. This is again an MSQ, so we may have multiple correct options. Okay, let's first try to decode what is happening over here. So we have a train, then we have a station, then we have A. Okay, so we are iterating over rows of A. What are rows of A? Rows of A. What are those?
For each rows in that train.
What is yeah? That is what is row representing? From row, if I take R, from rows, if I take R, what is R?
Arrival station.
It is some station. We are not talking about arrival or destination yet, but it is
It
some
may be,
station. Okay.
maybe initial or terminate.
Repeat that.
It may be initial station arrival or initial. We cannot say. Yeah. Anyone.
So when you are talking about rows, it's this direction, right? So this is basically your source station. Okay. So rows are representing source station and columns are representing destination. Okay. So departure and arrival. So R is basically one of the source station. So I'll just write source station. Now over here we are checking if is key A of R station is equal to train. There is again the string. So the spelling is incorrect, but let's see. So we are checking whether train is part of A of R of station or not. Okay. So what is this? First of all, A of R of station, if we say. So this is our source station or departure station. Okay. This is our arrival station or destination. Okay. So let's see. Let's write arrival, let's say. Now we are checking is train presented this or not. So this is what? This is the same dictionary that we were using earlier. So it has the mapping between train and distance. True? Any doubt? Okay. So I hope there are no doubts. So we are just checking whether in this particular dictionary train is there or not. Okay. If it is there, then we are doing this thing. So now we are doing what? We are checking the columns. And again, we are doing the same thing. So this we are doing, and then we are returning false if this is true. Otherwise, we are returning true over here. Otherwise, here we are returning false. Is it clear what is happening? Am I audible?
Yes, sir.
Yeah, this
Yeah.
line fifth, please one time more.
So you have some station given, you have some train given. Okay. So line number 3, you are checking whether that particular train. So let me write in terms of destination also. Okay, for some hour and just station. Okay, you are checking whether train is there or not from some source R, and destination is fixed because we are passing over here itself. So in line number 3, you are checking that. If that is the case, then you are moving inside and then you are checking this part. What is that? So now you are moving from station towards C. C is some again some destination. Okay, this is your source. This is your destination. Again, you are checking some train is there or not. If that is the case, you are returning false. Otherwise, if this case is not true, okay, then you will return true. Is it clear?
Okay, okay.
What are we trying to achieve?
Yeah.
So we are basically saying if from some source station, if we take a train T, okay, I'm saying T for this one. If we take a train T and we are able to reach this station, okay, the destination station, if that is true, and from that particular station itself, we are able to go to some other destination, some other station by the same train, then we are returning false. Otherwise, we are returning true. Is it clear now?
Yeah.
Let's see the options then. So option A, some proc returns true if station is the starting station for train. Is it true or false? So for some hour, we were checking whether T train was able to reach a station or not. So that is the top level condition. And then we have inside that, if that is true, then we had this condition. If both are true, then we were returning false. Otherwise, we were returning true. So what do you think? Option A, is it correct or incorrect?
Yeah, it will be standing the starting station. Yeah, it may be correct.
Maybe.
Yeah.
We are returning true over here. So
Some PO. Returning. Yeah, it will be correct.
are you sure?
Yeah.
It's incorrect because
But according to that,
according to what?
tell me that what is that problem in that statement?
Okay, so first of all, if you are returning true, that means this statement is incorrect, right?
If you means that it returning false, that's why that then after it will correct.
In the statement itself, it is saying that if some proc returns true, then STN is the starting station or source station, right?
Okay, yeah.
So if you are returning true, then that means the station is
Yeah, that's yeah, definitely.
Destination or
Des-
destination or arrival station. Okay, so this one is incorrect.
yeah, and definitely B option correct.
B, again, we can argue about this. So you think B option is correct. So why do you think option B is correct?
Because if the arrival and that is not true, then after option B, it will be.
So some proc returns false if station is the starting station for train. So for from this particular statement, we can check that if we are returning false, then station is the starting station for train. Okay,
Yeah,
option B is the correct option. What about C?
some procedure returns to it. Yeah, yeah, it is true for ending. Yeah, true.
This is true. It's just the inverse of this one. It's
Yeah,
true.
it is definitely true there because it is not for starting, it is for ending. That's
Yeah. What about option D?
we cannot see that screen, sir, please.
Okay.
Yeah, okay, okay, sir. For option D, it will be false.
Option D is false.
False.
Okay. Option B is correct. Option C is correct. Option D is false. Option A is false. What about option E?
Some procedure returns true if intermediate station. Sir, just please explain that intermediate term in that pseudocodes, please.
Intermediate is the same thing, no? We have some, like, you're traveling by a train. Okay, it reached some station, and then you went to some other station. Yes, right. Okay. Now it is saying that if we are returning true, then STN is basically the intermediate station.
Then, according to that statement, I think it will be true that because starting node there is intermediate.
So let me go back to what I had earlier. So if you are returning false, that means this is true and this is true, right? We are talking about
Yeah,
option E, right? Option E. If you are returning false, then these two options are correct. These two lines are correct. But if you are returning just true, that means this particular thing is incorrect. True?
yeah, only this.
So only this is correct. So if only this is correct, in that case, S is what? STN. STN. The station is what? The terminal station or destination. Okay, so this is also incorrect. What about option F?
Yeah, yeah. Then after it will be true. Yeah,
This is true.
yeah.
What about option G?
And option C.
G,
Some
G, G. Are you able to see it? Option G. Sorry.
and
Option Z.
this is also not correct, sir.
Some proc returns true if station is not on train's route. This is false because we were returning true when the station was able to reach from some source station to STN.
If in that line, if there is nothing any note, then it will be correct. Suppose the same statement
Yeah.
there. Yeah.
Yeah, yeah.
Okay.
What about option H? Are you able to see it?
Yeah. Some procedure.
Okay.
Oh. Yeah, it will be true. Yeah, option H is correct.
So which line do you think represents that in the pseudocode?
In that,
From where are you interpreting it?
Yeah, I think that option in line 3.
Line 3. Okay. So if that is false, if that is not true, then you will come over here, then you will return this. So this false is basically returned in that case. For the
Oh,
last option, this particular false is getting returned, not this one. Okay.
okay.
I hope this is clear. We marked some options. Let me quickly mark those. B we marked, C we marked. I believe we marked F.
And option
G
H.
we didn't mark, and H we marked. Yeah.
H is true. Yeah.
Okay. I might be able to take one or two questions and then we will discuss in the next session. Let me plug this in.
Battery is about to die.
Yeah, let me plug this in. Okay, am I audible?
Yeah, sir. Yeah.
Okay. So question number 6. Assume there are n stations in the train's dataset indexed from 0 to n minus 1. Consider a graph with the stations as nodes. Okay. There is an edge from station I to J if and only if there is a direct train from I to J. The graph is represented by a matrix direct, okay, such that this if there is and zero other, okay. Assume that direct has already been computed and direct is non-symmetric. Matrix station J is reachable from I if we can uh, uh, a non-empty sequence of trains that we can find a non-empty sequence of trains that take a passenger from I to J. In other words, J is reachable from I. If there is a non-empty sequence of edges that connects I to J in the graph. Okay. Is this stem clear? What are we trying to achieve over here?
Suppose that.
Okay, so we have a matrix direct given. Okay. So direct is basically in the beginning of this session, I showed a direct matrix, one hop matrix, two hop matrix, these kind of things, right? So direct matrix is the same matrix. So it is basically, it will have one for stations. Like suppose there is a station I, J, and there is a train, direct train between them. Okay. So there is a train, some train T. If this is possible, then in the matrix we will have 1. If they are not directly connected, then we will have 0. Okay, so direct matrix is just representing this relationship. Now we are talking about B. Okay, now for B, it is saying that station J is reachable from I if we can find a non-empty sequence of trains that take a passenger from I to J. In other words, J is reachable from I if there is a non-empty sequence of edges that connect I to J in the graph. Okay, now we are calculating the B matrix. The dimension will be same because the number of stations are not changing, so the dimension will be same. Now over here we are saying that B of ij will be 1 if and only if j is reachable from I. Okay, all the other entries of B are 0. Now I'll move to the pseudo code. And in the pseudo code, you can directly see that we have one more hop procedure defined. Okay. And one more hop will basically do what? It will calculate, it will help us calculate the one hop matrix. Okay. So we have to calculate this, and this matrix we are storing at. Okay, so it's taking this. So we are basically just checking whether we can reach from I to j at all or not. In 0 hop, in 1 hop, in 2 hop, in 3 hop, so on. Okay. The number of hops doesn't matter. We just need to check whether from I to can we reach j or not. From I we can reach j or not. Is it clear? Anyone?
So please, one time more explain that in second paragraph that station is a, yeah.
Okay, so we are saying over here, the problem is saying that station J is reachable from I if there is a non-empty sequence of trains. What does that mean? So from I to some K station, we took train T1. Okay. Now from K to J, we took some train T2. Okay. Now we can say that from I to J is reachable. It is just trying to say that we have a non-empty sequence of trains between J to I. Okay. Sorry, I to J. If we are saying that J is reachable from I, then there is a non-empty sequence of trains that we can take to reach J.
Okay.
And this relation we have to return in matrix B. So it is not talking about one hop, two hop, that kind of thing. It is saying the number of hop doesn't matter. You can take as many hops as you want, and as many hops as you want, and it's possible. So you have to take both things in the consideration, and then based on that, you have to create the B matrix. Okay.
Yeah.
Is it clear?
Yeah.
Now, if that is clear, some part of code, some piece of snippet is missing from this pseudo code, and we have to basically check that in question 6. So let's try to first go through whatever we have right now. So what is n? What will be n is representing what?
The number of trains length.
Number of trains or number of stations?
Yeah, number of stations.
Okay. Number of stations. B is initially B is just a matrix. We have initialized it. Okay. Now we are putting the values. So in the values, in the beginning, B of RC is direct of RC. That means in the beginning, B is the direct matrix itself, right?
Yeah.
Okay. Now we have hops 0. We have initialized it, and we are continuing until n minus 1.
Okay. Yeah.
Okay. And in this, we are using one more hop, which is
It means that maximum of the relation contain n minus 1, not only n.
So it is containing n minus 1 because
Because if I because myself comparing with 9 because some, for example, we are 10 people. If I comparing to myself comparing to 9, then that's why it is n minus 1.
yeah, that is fine. That is true.
It means I cannot include on them. Yeah.
You're talking about hops, and they are only possible if you have pairs, right?
Okay. Okay.
So that is why n minus 1. Yeah. Now over here we are iterating over the rows and the columns. So basically it will just give us what? One cell, right?
Yeah.
Now we have to calculate this particular thing. What do you think? How can we calculate this?
BR of RC.
Okay, let's go to the problems and see there. Okay, we have the options and it might be easier to figure out there. Okay, so let's see what we have in question 6. So it is actually just asking for the same thing, the same missing code. So the pseudo code is incomplete. Select the code correct code fragment to complete it. It is an MSQ. So option A, do you think it is the correct option or do you think it's incorrect?
B of RC is assigned equal to 1. Then no, because why this exit loop in that
Exit
firstly?
loop is basically suppose you are trying to check some condition and the condition is true for more than one element. Okay, and you are just checking whether that condition is true or not.
So
Okay,
in that suppose in that option A there is exit loop. Then after if condition executed and then in the same line and B of K and C. Yeah. Then why it is B of RC is equals to 1 in that line 6?
that you have to figure out.
Yeah, that is also
In this, we
I
are
think that
saying that B of RC is equal to 1 or not. Okay, we are checking this. What
yeah,
does that? What does this mean?
it means there will be a relation between R and C.
We are basically checking whether there is direct
Yeah,
in the first iteration. We are checking whether there is a direct train between R and C or not. Right?
yeah,
If we found that,
yeah,
we don't need to continue ahead. Right? We can just return or
yeah,
exit. Correct?
yeah,
So if this is true, we don't need to do this. Okay, this part is not needed. But if this is not true, then we have to check whether there is some intermediate train, station.
yeah. Then after we check that there is a intermediate trend between R and K or K and C. Yeah,
Yeah, this we will check. And if we found both the conditions true, then we can say that this is one, and then we can exit the loop. True.
okay.
So option A, do you think is it is the correct option? One of the correct options?
Sir, I am confusing in that line 6 because if B of RK is equals to 1 and B of KC is equals to 1, then why it is R of C is equal to 1?
We are saying that from R, we are able to reach K by using some train T1, and from K to C, we are using train 2, and we are able to reach C. Okay.
Yeah.
If both of these statements are true, can we say we can reach RC by using
Yeah, because because there is distance. We have a path to travel from R to C. Yeah.
yeah. So now this path we have to represent, right, in B.
Okay,
So
okay.
that's why we are assigning 1 to RC.
Okay, sir, understood. Yeah, I think that it is correct option.
Okay. Since this is an MSQ, option A is correct as we mentioned. What about option B?
For option B, for each K in column B, P of R K.
Sir, R and K both are stations,
Yeah, both are stations.
and K and C, they are also stations.
Yes. All of them are stations only.
I think that B option also correct. Yeah, because
Why do you think so?
because if that condition true, then we do not require to check R of C.
But this part is not there.
Yeah. If execute this code without that part, so what is that problem, sir? If
Yeah, I'm asking whether this will work or not, even if we don't have this particular code. Will it work?
I think that it will work because there will be no in that option A also that is not requirement because
Okay. So basically what we are doing over here is, suppose we have a matrix, right? And these are zeros. From here we are able to, let's write this. Okay, so from 1 we are able to reach 0, and 0 from 0 we are able to reach 2. Okay. Now, if we do this for this particular element, it will just return 1. Okay.
okay.
It will exit the loop. It won't do anything. For this, now we are changing the values in this matrix itself. We are not creating a new matrix, right? We are changing the values for this
Oh.
matrix itself. Now, here as well.
So basically in that option A, we are firstly we have to check that what is the shortest what is the shortest path between R and C.
Shortest is not needed for this one. We are just checking whether C is reachable from R or not.
Okay, okay, okay.
Shortest is not necessary for this one, right?
Okay, okay, sir.
Now, this is again the same matrix. Okay. Now we are doing some operations. So first of all, we need to check this is true for which cell. So for this cell, it is true, right?
Yeah.
So B of what we can write? 1.
Yeah.
0, right? It's true for this one. Now for 0, comma 2 or 0, 2, it is also true, right? This one,
Yeah, obviously.
right? Now, these two, as you can see, they are same. K is same, right?
Yeah.
0, 0 is same, right? So we can say B
That
of 1,
and 2 also, yeah.
this is same. So that will make which element flip? This one?
Yeah, yeah.
And all the other element will remain as it is. So we don't need this part, right?
Yeah.
This is not required because we already had the direct connections in the matrix, and we are just switching the elements which are not representing the one hop condition.
Yeah, yeah, absolutely. Yeah.
Yeah. So option B is also correct.
Yeah, yeah.
Option A B is correct. What about the option C?
Sir, please scroll up that screen. Okay, sir. Okay, sir. Talking about rows, it will false because In that each row we cannot find. Yeah, it will be false because
We are picking the rows. Previously, we had columns, right?
yeah,
Okay, so columns will give this and rows will give this.
yeah,
So do you think this is incorrect? Option C is incorrect.
yeah. That in I am confusing, sir. That when did we do assign it to column and rows? So, sir, please one time explain that options.
So basically, this is also correct. This option is also correct. Why? Because this is just a list, right? And this is also a list, correct? Columns of B and rows of B.
Okay, yeah,
And they are basically representing the same thing, the same list, right? So if you switch columns with rows, it won't make any difference because columns is representing the stations, all the stations, and rows is also representing all
okay,
the
okay.
stations.
Yeah, yeah, yeah.
Right?
Understood. Thanks, sir. Yeah.
And internally, you have to check that these are the same thing. If they are changing, that means one of the options is incorrect. But if rows is switched to columns, that will be same. The options will be same. Okay.
Yeah.
What about option D?
Option D is also true.
Why do you think so?
I'm confused. Yeah. Is there any difference between B and D?
So option B is saying that from R we can go to K, okay, and from K we are reaching C. But
Yeah,
option D is
yeah,
saying
yeah. Option
from,
D. Yeah, it will be false.
yeah, it is saying from K we are able to reach some R, and from K we are able to reach
Yeah,
some
it will be
C.
definitely false. Yeah.
Okay, so option D is incorrect. Option A, B, and C are correct.
Yeah, yeah, yeah.
Any doubt in this one?
No, no.
Anyone? Okay, I hope there are no doubts. So option A, B, and C are correct.
How option C
Consider
is correct, sir?
option C is basically okay. So when we say columns of B, I'll just write columns of B. Columns of B will give what? List of stations,
Yes.
right? And what about rows of B?
Rows of B also list of stations.
So if this is same, we are using the same variables and internal conditions are same. Both options are same, right?
नहीं मतलब in C what they compare, they compare through the rows na.
Same thing. So at the top level or K you can say, okay. So K is one of the stations, right? K is one of the stations and we are using the same notation, okay? The same thing in both the options. So if we are saying that B of R, K is suppose 1, okay? And R is R, let's see, let's take R as 2, okay? R is basically 2. So in this, which element will you target? Which cell you will pick?
K in rows. So there is the confusion. If it is rows, then
Yeah.
this
For just question, bro, you understood that row is equals to column. So that's why you
Yeah.
easily understand.
The stations are not changing. No. In rows we have the stations. In columns we have the stations. And the stations are fixed. So rows of B is equal to columns of B.
now that then how it is compared? Suppose this is the if it is compared row by row, so it is a 0 row, that is the first row. 1 is the second row. So for first it will compare 0 to 0, first to first row. This way.
Could you repeat
Then
that?
it is comparing row wise, na? So row wise means how it is comparing means because each
One
row
second.
has
Let
two
me
column.
show you.
एक का रो होगा, एक का कॉलम किया जाएगा, दोनों नहीं.
See, over here we have already picked R and C. Okay. So the rows and columns are already picked. Okay. Two things are already picked. Now we are picking K. K is one of the stations. Okay.
K is one of the station. Okay.
Now we are saying this. So R is some station. Okay. And K is also some station. Now in this matrix, R and K are what? Some stations. Okay. Based on R and K, you will target some cell, right? You will pick some cell, and based on the value in the cell, you will say whether this is true or false, right? Again,
the confusion is just that key when we take it as a instead of column as a row. Uh, just pick one example that if it is row, then what will that depict? Just
okay, let's
put one
change.
numerical value in R and K and just.
Okay, let's change this a bit. Okay, I'm changing this loop a bit. So for K in columns of B, okay, and I'm just printing K. Okay, I'm just printing K. For K in rows of B, I'm again printing K. What do you think? The values which will be printed by this.
Values will be same. Values will be same.
Okay, if this is same, and before this, the R is same and the C is same, because the outer loops are the same in both cases, right? So R is same, C is same, K, as you mentioned that based on this, you mentioned that both are same. So all the three variables that we have, they are same, right? And B is also
Variable
not
same,
changing.
but the column and the row that is in changing. So if it is instead of column, if mention it as a row, in the C, if we mention BRK, suppose BRK we depict as a B1 2 means row number 1, then
Basically,
again
symmetry.
row number 2. That's what it is mentioning, or what it is mentioning.
Do you want to add something? Someone was saying something, I think.
No, I am telling that the person that it is to understand them, it is a symmetry.
Yeah. So when you execute this code, okay, right now we are just trying to do the things by hand only. Okay, when you start running these things on the computer, what will happen is it will basically change this value, the columns of B, to what it actually is. So columns of B is what? this value. 1, 2, 3, not 1, 2, 3.
0, 1, 2.
It's, yeah, 0, 1, 2, or you can say
One.
S1 or S2. Okay, so it's basically the list of stations, right? It will again go to rows of B. It is also list of stations. Right now I am using S notations, S1, S2, S3, but in the matrix it will be represented as 0, 1, 2 kind of thing. Okay, so now the computer just sees these things. It is not able to like see rows of B, columns of B's. It is not able to see. It is just seeing these things. Okay, and you have to interpret it like this only.
Acha,
So
acha, acha.
both
Computer
are
does not
same.
differentiate this. Acha.
It's just the pointer. You have the variable name, so some variable name is there, and you have some pointer. Based on that pointer, you get the values. Okay, you check the pointer where it is pointing to, and then you have some memories where the actual values are stored. Okay, is it clear?
Means the system does not differentiate this row and column in that way. That's why it is depicting the
Yeah,
same
so
thing.
it will basically see something like this. I'm just giving an example. This is not needed, but I'm just giving this example. So variable 1 is your columns of B. Okay, you can assume, and variable 2 is your rows of B, and both have pointers. Both have pointers, and they are pointing to the same value. Okay.
Exactly. Got it.
Yeah. So option A, B, and C are the correct ones.
Correct.
Let's move to question 7. Consider the following graph for the case n is equal to 5. Matrix B is computed using the above protocol. What is the value of sum after executing the following protocol? Okay, so we calculated matrix B. Okay, we calculated matrix B as someone's mic is on. Can you please turn it off?
Please unmute your sir.
I'm not able to do it. Okay. We have the same B matrix that we calculated in the previous question. Okay, it is basically representing whether station J is reachable from I or not. Okay, it's representing the same thing. Now we are using that same matrix, and we are doing some operations, and based on that we are calculating sum. We have to figure out what is happening over here, and based on that we have to tell what will be the value of sum at the end of the execution. So I don't think this is very complex. So I would like you to see this
Yeah,
thing and the
I think there
pseudocode.
is a very less sufficient data for me. But
Less sufficient data. What did you say? Less sufficient data.
Yeah, according to seen by question, I think that
You have the graph. Okay, you have the graph, and based on this graph you can calculate or create this matrix, right? From 0 you will check whether 1 is reachable or not. If it is reachable, then you will keep the value 1. If it is not, you will keep the value 0. Then you will do for 2, 3, 4. So you will populate the matrix based on that, and then you will calculate the sum. So let me write that. Okay, let me create the matrix, and then we can proceed. So we have 0, 1, 2, 3, and 4. Okay, 0, 1, 2, 3, and 4. So So from 0
0 is a 0 to 1. There is a 1.
we are talking about reachability, so let's keep this one because they are reachable. From 0 to 1 we can reach, from 0 to 2 we can reach, from 0 to 3 we can reach, 4 we can reach. All of them are basically connected, right? So if you are at 1 you can reach all these,
Yeah,
right?
basically, it will forming a circle.
Yeah, it's circular only. All of them are connected, so I'll just write 1 for all of them.
Yeah.
So can you tell me what will be the sum? It's basically adding the cell values. Now in the cell we
16.
have only ones. 16 or 25? We are going from 0 to 4.
Okay, now 0 to 4. Yeah.
25, right?
Yeah, 5, 5, 25. Yeah, very good. Yeah.
Let's move them. It's 25 only.
Yeah.
The following
Any square.
pseudocode executed using the trains dataset as discussed in the lectures. Assume trains is a dictionary with train numbers as key mapped to a list of stations which that train runs to. Okay. In this example, the train with train number 2 starts from Bhubaneswar and reaches New Delhi via Bangalore, Adra, Varanasi, and Kanpur in the order. This returns the number of common elements between lists L1 and L2. Observe the following pseudocode and answer the given question. Okay, so trains, as mentioned, it is a dictionary and it maps a particular train to all the stations, right? Now we have one method given which we can use to return the column element between list L1 and L2. Okay. Now we
Yeah.
have some pseudocode given over here, and I think we need to let's see. Let's first try to check what is being returned over here. Okay, what are we returning? So we created two variables, I and index, and for keys of train. Keys of train is what? Right? Keys of train is this.
Yeah. Number
List
of
of train ID. Yeah. Now we are just assigning some index to each of the train IDs. Okay. So it will be something like 1 for maybe train 251, this kind of thing. It will store. Right? Index. So index will store something like, oh, sorry, it's inverse. So it is storing the train ID and it is mapping it to some number. Correct? So this will give us the index. Now we are saying n is equal to this. What is n representing?
Length of train. Sorry,
Number of
station.
trains. Number of trains.
Yeah, yeah.
Okay. So number of trains it is representing. Now we are initializing a matrix, and over here we are populating this matrix. So let's see what we are trying to achieve over here. So we picked two trains, right? T1 is one train, T2 is the second train. We are saying that they are not the same train. The ID is not the same. And then we are checking this. Okay. And based on that, we are creating this. So this is basically representing common elements between L1 and L2.
Yeah, there is
okay.
nothing to be duplicating there.
Yeah. So for this, what will it return?
And it will be include T1 and T2 both.
Even not T2 both. So trains is what? 1 second. Trains is
It was creating the list of unique train ID.
I'm talking about just trains. In the problem statement, it is given. Okay. So this is the format for train. Okay. Now if
Yeah.
we say trains of T1, what will this return? All the stations that particular train visits, right? True, right?
Yeah, all the students are that connected to the train number because when they arrive at
Yeah.
point. Yeah.
Same thing for this one, T2. Now we are picking the common stations. Okay.
First of all, it try that T1 not equal to T2, then it will be fetch at the common station in them both.
Yeah, common stations between two different trains.
Yeah.
Right.
Okay.
And now
Yeah.
we are assigning that value to the cell for that particular pair.
Yeah.
Okay. So this is what we are doing in do something. Any doubt in this one?
No.
Okay. If that is the case, let's move to the questions then. Just counting just the numbers. It is 1 second. It is returning the number of common numbers. Okay, so it will store the number of common stations. Okay, not the list itself.
Yeah.
Now, question 8 is saying that if this is given for I not equal to 0, sorry, I not equal to j, then which of the following can be concluded? Option A. What do you think? Is it the correct option? One of the correct options?
Yeah, it will be correct because if not equal to then it will be no root between.
Option A, you think is the correct option. There is no route between stations which include which indices using one hop.
IH.
Why do you think so?
Because if I and J both are common.
There is no route between stations with indices this and this.
So that what
Using
is the meaning with index is I and J?
indices I and J is basically station ID, you can say.
Okay. I,
What do you think? Option A is the correct option?
someone's mic was
I'm not able to mute because I don't have the co-host access for this call.
I think that in option A, for no routes between station with indices I and J, this statement is not sufficient.
You can't basically interpret this, right?
Okay.
Okay. What about option B? There are no common trains between stations within different distances. This was we are saying no common trains, but this matrix was storing the number of common stations, not the trains. We can't interpret this, right? What about option C?
Yeah, it will be. Yeah, it will be correct.
Option C is the correct option. Okay.
Yeah, yeah.
So let's see the options. Sorry, correct answer. Yeah, that is C only. Let's.
Yeah.
I think this is the last question. So let's try to do this and then we'll wrap up. Assume we start our journey using a given train T. Now consider the following procedures. They should return true when it has at least one common station with all other trains. Assume we start our journey using given train T. Now consider the following procedures. They should return true if it has at least one common station with all other trains. Is the stem clear? So the procedure should return true when for a particular train T, if we compare
At
the
least,
station with all the other trains,
at
there
least
is
one
at
station.
least one common station between them. Okay. They can be
Yeah.
same, they can be different, but there should be at least one common station.
Yeah,
Okay.
it will be more than one, at least one.
Yeah. So we are using the same do something trains that we defined earlier. That was defined in the previous question. Okay. From there, we are getting CMAT and index. CMAT is what? Each element of CMAT, each cell in CMAT stores the number of common stations between two trains. Okay.
Yeah.
K is equal to index of T. So index we created, if you remember. Index was created over here, right? So that same index we are returning.
Okay. Yeah.
Okay. It's just the mapping between. Okay. Second. Yeah, so it's just mapping the trains with some ID. Okay, train ID with some ID index.
Yeah.
So now we are picking the ID, right?
Yeah.
From that, we are just pulling out the ID for that particular train. Then we are iterating over the columns or columns of CMAT. If I is not equal to K and this is equal to 0, return false, otherwise return true.
What's that line? Fifth CMAT KI is equals to.
CMAT was basically, we created CMAT in the previous question. It was representing, suppose this is 0, and not this one. Okay. For this particular cell, this is train 0. Okay. This is train 0. This is train 1. Okay. And in like they visit some stations, right? S1, S2, and so on. They both visit. And they have suppose 3 common stations. Okay. So 3 will be stored over here. So CMAT is basically representing this.
Okay.
Now we are basically K is fixed and we are iterating over all the I's. So I's are what? The trains, right? So we are checking all the trains. If the train is not the selected one, we are checking whether the common elements is common station is 0. right? If that is the case,
Yeah.
we are returning false. And if after completing the iteration we were not able to return false, then we will return true. It's doing the correct thing, right?
Yeah, it's but yeah, it majorly I think that it will be.
Any doubt in this one?
No, no.
Okay. That is the case. Let's move to the next one. This procedure is also trying to do the same thing. Count is equal to this for T2 in keys of this. If common number trains of this greater than 0, then we are incrementing count. Count is equal to length of keys of trains. Then we return true, otherwise we return false.
Count is equals to length keys. It will.
Length of keys of trains. Yeah.
Okay.
Length
Yeah.
of keys of trains will be number of trains only, right?
Yeah. Number of trains. Yeah.
And over here we are populating or incrementing count. So do you think the incrementation will give you the correct number of trains?
No, because in that incrementation there will be some train between common and some not. So
Common and some not.
yeah, because there will be strictly in counting.
So what we are doing, see, we have some. No, we are not using the matrix over here. So we initialize this, and we are picking one train T2. Okay.
Yeah.
And T1 is T is fixed, right? T is some train that was given to us. Now we are
Yeah.
using this function. Do you remember what this function was doing? It was
Common between
it was
them.
taking two lists and it was giving away the number of common elements between them.
Number of yeah.
So this will basically return the number of common stations between train T and T2, right?
Yeah.
Now we are checking whether that is greater than 0 or not. If that is the case, we are incrementing count. Okay.
Yeah. If greater than 0, that it will be yeah. Count is correctly represent that. Yeah.
Count is correctly represented, and
Yeah.
if count becomes equal to number of trains,
Number of
then we
trains.
are returning true.
True. But that that means create a big mistake. Yeah. But count is equals to train length. It is.
Any doubt in this one?
No, no, no.
Okay. So if this is not equal to this, okay, then it will just give the number of common stations between these, okay, and count will be incremented. Now if both are equal, okay, meaning we are using the same train, then again we will also increment count, because if we are using the same train, the number of station, the number of common stations will be same as number of stations for that particular train, right? For this case.
Yeah.
So in that case also we will increment count. So count will represent all the trains. Okay. Now since we are representing all the trains, and we can directly compare this. Now suppose in this we had one more filter, that T shouldn't be equal to T2. Okay. If that filter was also included in this if block, then instead of using this, we should have count should equal to length of keys of trains
Yeah, there will be a
minus
requirement of T1 is not equal
1.
to T2.
Yeah. So minus 1 should be there if we have this as well. Okay. But that is not there.
Yeah,
So we'll just compare like
it
this.
will.
So
Yeah,
both the procedures are doing the correct thing that they were supposed to do. Let's see what the question is asking for. Which of the above procedures works as intended? Both, right? Option A
no,
is
yeah, but no, not
incorrect. Incorrect.
option C. Option C.
Okay. So
Yeah,
that's it for this practice assignment. And now we will close the session as well. In the next session, we
yeah,
will
sir.
discuss. Yeah.
I have a doubt that, sir. Yeah, sir. In that my quiz one, I score in mathematics. There is a 43 marks. Yeah, and in that quiz two, I score only 22. So I need to focus on that end term examination because it is very poorly marks.
Okay.
Yeah.
So
So I do not know that how much marks I need to score in that end term. So just I passed that course.
so you have grading doc, right? Access to grading doc.
Yeah.
If you have, you can just look into that. All the details are there, and based on that, you can do the calculation. If you don't have access to that document, just email to support.
No,
They will share them.
I have, but I cannot understood them because
You are on mute.
yeah, I do not understand that because why that?
What you can do is you can just either write to support or one of the instructors from math. It's maths one, right?
Yeah, yeah,
Just email them and also provide your marks for quiz 1 and quiz 2. They will check and let you know. Okay.
yeah,
And also mention that you
yeah,
are not able to figure out from the grading doc. Otherwise, they will just tell you to refer the grading doc. Okay.
yeah, yeah, yeah.
Okay. Okay, so that's pretty much it for today's session. In the next session, we will discuss week 11. Yeah. Any other doubt?
Yes, sir.
Yeah.
Sir, I'm having difficulty scoring in computational thinking. Like, sir, like the first few weeks were fine. I was able to do well, but now, sir,
Mm.
I'm facing difficulty while solving the coding questions. Like in some questions, I'm able to solve and I'm able to score, but there
Okay.
are also questions where like the idea and the concept that I'm using uh, in the previous ones, uh, the same idea and the concept is not like not getting me the full marks. Somewhere or the other, sir, I'm getting mixed up. So, sir, how should I, uh, you know, increase
You
my
need to do
scoring?
more practice. Okay. The concepts are fixed, right? And the nature of problems are also fixed. It's not like we are asking something which is not in the syllabus, right? All the things
Yes,
are
sir.
already in the syllabus. So what you can do is try to solve all the practice assignment and graded assignment on your own, and also solve like 2 to 3 previous year question papers at least, right? That should be the minimum. So try to solve all of
Yeah,
them,
for
and
standalone,
when you
for
solve those
standalone.
one
Okay,
second.
sir, continue. Yeah,
When you solve the questions, what you can do is in the session itself, what we do, we just instead of seeing the options directly, first we go through the code, right? Whatever pseudocode is
Yes.
provided, we just go through all of the code, and the variables which are not which are initialized, and we have to target those variables. So first from the code itself, you need to figure out what is happening. Okay, go line by line and try to figure out. Note the data types if you want, and based on that, solve the pseudocode. And once you are done with that, then move to the code. Sorry, question, and see what is asking, and whether do you need to do more calculation, or do you have the answer on your hand. Okay.
So, and one more thing that I'm finding difficult is, so like in the coding, there are certain functions given, and then so the more stuff is given inside the brackets. So sometimes I'm getting confused, like what is the function actually doing and what it's returning the value.
Okay, so return values are always there with return key, right? So that
Yes,
you need
sir.
to figure out. And for the parameters that we pass in the function call, okay, procedure call. So the order remains the same. Suppose you have a procedure, maybe do something, and it is accepting maybe 3 or 4 parameters. Okay. So when you
Yeah.
are passing those parameters from the top level, whatever data type you are using, whatever variables you are using, those same thing will be passed to the function, okay, or procedure. Just the name of the variable will be changed inside the procedure, but the variables will remain the same. The values will remain the same. Okay.
Yes. Okay.
If you are still like try to solve some questions. If you are still having some issues, then we will have some more sessions. So in those sessions, you can bring up some questions and we can discuss deeply. Okay.
Okay, sir.
Yeah. uh, I think someone was mentioning something. Do you want to
Yeah,
add
yeah,
something?
sir. Yeah, sir. I have
Yeah.
doubt. Suppose, sir, if I was failed in that maths one, then should I take with continue with maths two state two along with them?
Maths 2, I won't suggest you to continue Maths 2, because Maths 1 is prereq for Maths 2. So first try to clear Maths 1, then go with Maths 2. It's Stats 1 and Stats 2 has also some concepts related to Maths 1 and 2. So I won't recommend that.
Yeah.
Okay. So try to complete Maths 1 first, and then proceed with the Maths
No,
2 and
suppose suppose in case we failed out, then can we choose that English two also along with them so we can continue with because we have that 4 months to complete this course because but we get more time to take one more course so it will be easy for.
you can check with support. Okay, it is allowed in my opinion, but you have to check. Okay, check with them once, and they will let you know.
Yeah, and also I'm asking that what is the most preferable for us if someone is preparing for civil services also along with that standalone? How much courses did took in a term?
That I can't answer. That I am not able to answer. Okay, so
For
that thing you
according
have
to
to check with support.
manageable, for according to manageable, how much in your view?
I mean, the initial courses are not very hard, so you can go with 4 as well if you are able to do well in all of them.
No,
But
in foundation, I took that 4 4, but in I am asking for diploma level. What is that? See,
diploma level is hard. Diploma level is hard because all the courses are like in foundation, the courses are related, right? Maths 1, Maths 2 are related. Then Stats 2 has some concepts from Maths 1 and Maths 2, right? This kind of pattern is there. But diploma level courses are like you can say they are mostly independent courses. So you will have to uh, basically start from the scratch and then go to some level.
so
So I won't recommend
so
you to take 4 courses there.
yeah.
That's it, right? Okay, so now I'm closing the session, and in the next session we will discuss some questions from week 11 and theories as well, most probably. And if you have any doubts related to some questions, practice assignment, graded assignment, and other things, you can ask. Okay, thank you.
Okay, sir. Thank you.